In lesson 411, we are continuing on with domain and range. And in problem 11.2 specifically, we're dealing with a child on a swing in a playground. They're going to swing for 30 seconds and then get off the swing. So we're given 4 descriptions of scenarios, and we have to match them up with a graph. And now importantly, they tell us in every single situation, the independent variable is time, which tells me right away that in every single problem, the input is time. So let's look at our first example. F of h, the height of the swing in feet as a function of time since the child gets on a swing. Well, when I think about this, if you're on a swing and you start swinging back and forth, your height goes, you start at the bottom, and then it goes up and down and up and down and up and down and up and down over and over and over again. And then eventually you kind of slow down your swinging and you stop and get off. So I need a graph that goes up and down and up and down and up and down, which is exactly what graph D does. So on graph D, this is time down here, and this is height, which means that f of h matches with graph D. The second situation is f of r, the amount of time left on the swing as a function of time since the child got on the swing. Well, if I'm only allowed to be on the swing for 30 seconds, when I start, I have 30 seconds left, and then that time just goes straight down from there along a constant line, which means that this must pair up with graph A, where down here is time, right? How long have they been on the swing? And over here is time remaining. How long is left on the swing? Next one, f of d is the distance in feet of the swing from the top beam as a function of time. So in this case, if I think about a swing, you're pretty much always the same distance away from that beam because the rope or chain or whatever it is always taut. It's a straight line. So the distance from the beam should be constant. It shouldn't change, which means this must pair up with graph C, and this is time still, and this is now distance. Specifically, distance away from that beam. So graph C. Well, that leaves only graph B, but let's make sure that it works. The total number of times an adult pushes the swing as a function of time since the child got on the swing. Okay, so at the beginning, maybe they haven't pushed the kid at all. And then they push the kid once, and then they push the kid twice. And the important thing here is that this function is never going to have an output that is a decimal. It's going to jump from 0 pushes to 1 push to 2 push and so on. So that actually makes perfect sense with graph B, because here we can see, hey, I've pushed 0 times, and now I jump to pushing it 1 time, then I jump to pushing it 2 times, and so on. And the reason that we have these horizontal lines here is after they push the swing, they wait for a little while before they push the swing again. So this is number of pushes. And this must pair up like that.